Welcome to Writing a Proportion, Lesson 11-4. We're going to take a look right at some examples to start with. Example number 1 says, at a given time of day, a building of unknown height casts a shadow that is 24 feet long. At the same time of day, a post that is 8 feet tall casts a shadow that is 4 feet long. What is the height x of the building? Well, we have to first examine what information is given. We know the length of the building's shadow, we know the length of the pole shadow, and we know the height of the pole. What are we asked to find? We're asked to find the height of the building. Pause the video at this time if you need more time to complete those two problems. Now, since the triangles are similar and you know three lengths, writing and solving a proportion is a good strategy to use. It is helpful to draw the triangles as separate figures. Write a proportion using the legs of the similar triangles. I just noticed a typo. So we write a proportion. We have 4 over 8. 4 was the height of the pole shadow. 8 was the height of the pole. 24 was the length of the building shadow. And x is what we don't know, the height of the building. We can cross multiply and we end up with 4 times x is 4x. And 8 times 24 is 192. Then we're going to divide both sides by 4. So we find out that x is 48 feet. So the height of the building is 48 feet. Pause the video at this time if you need more time to copy down any of the information. Let's do some more additional examples that are not listed on your notes. Please put these on page 2 of your notes. Draw this shape. There are actually two triangles here. We know the length of the shorter triangle, or the base of the shorter triangle, and we know the base of the larger triangle. We know the hypotenuse of the smaller right triangle, and we're trying to find x. So we're going to start off by setting up a proportion. 13 and 21 are similar sides, so we have those set equal to each other. 20 is the hypotenuse of the smaller triangle, and 20 plus x is the hypotenuse of the larger triangle. Again, we'll cross multiply, and we're going to take 30 times 20 plus x and set that equal to 20 times 21. 13 times 20 is 260. 13 times x is 13x. 20 times 21 is 420. Now we're going to subtract 260 from both sides, trying to get x all by itself. So we end up with 13x equals 160. Next, we're going to divide both sides by 13. When we do this, we find out that x equals 12.3 meters. So the small section as part of the hypotenuse of the larger triangle is 12.3 meters. Please pause the video at this time if you need more time. Here's another example. Again, we have two right triangles. We know the legs of the smaller triangle, and we know one leg of the larger triangle, but not the other leg. We can still use a proportion to solve these problems. 0.4 and 0.6 are corresponding sides of the triangles. If we would rotate the smaller triangle so it was sitting right on top of the larger triangle, we would see that 0.4 and 0.6 sides are the corresponding sides. 0.8 is the corresponding side to x of the larger triangle. Again, we're going to cross multiply, so 0.4 times x is 0.4x, and 0.8 times 0.6 is 0.48. Now we're going to divide both sides by 0.4 so that we can get x all by itself. When we do that, we find out that x equals 1.2 meters. So the leg of the larger triangle that is missing is 1.2 meters. Please pause the video at this time if you need more time to copy down any of this work. You have finished Lesson 11-4. I challenge you to go to the phschool.com and take the online quiz. The web code is BJA1104. If you need extra help, there's a video tutorial from the textbook company. Its web code is BJE1104. Have a good evening. See you in class tomorrow.